Right. So stationary points. Right. So Alia, I want you to identify where the stationary point is on this curve. Where's the stationary point on that curve?
Um, over here. Wait up.
Yeah,
There.
right there. Right there. So the stationary point is also called, what's another name for the stationary point? What do you guys think? What is this? That's also called the what point?
Um, I don't know.
Think of it, or what do we call this? Um, Amy, if Alia doesn't get it, you could try to give it a go. What do we call this? What point? What is that? What is the name of that point? Alia, let me give you a hint. The gradient here, the gradient here is negative or positive? Are you not seeing the screen? You see
No.
anything? Hmm, it's weird. Yeah, you see the screen now?
Yeah.
Okay, cool. Uh, I'm not sure what's going on. The
I don't
cable,
see it.
cable giving trouble. Okay, it should be seen on the screen now.
Yeah.
Right. So what is a gradient here? Is it a positive gradient, a negative gradient? What kind of gradient is that?
um,
You're supposed to know
that's
these things like without looking back at any notes. You should know it. They should just be natural.
that's a negative.
That's a negative gradient here. And this is a,
Positive.
so we think it have in the middle. What's in between negative and positive?
Zero.
Zero. So it went from negative to positive. Hmm. Hmm. That's with T. You're going from
Um,
negative to positive. That's with T.
I want to say trend, but no.
Nah. What do you call it when you change? Like you become different?
A transition.
No, I wouldn't say transition point. Amy, do you know the answer? What's another name for stationary points?
I'm not sure.
What's when you become a new person, you reach at what point in your life? Like you decide to be a good person because of something that happened. So you reach at what point? So that's with T. You know, people just say like when you're getting influenced by, you need to do what's with your life. Like turn it around. So there's another hint.
A turning point.
Yes. It's another name for stationary point. They could also call it turning point. Instead of saying find any stationary points, you could say find the turning point. Now, Are there, if we're talking about stationary points, right, and turning points, is there just one type of stationary points, or is there two? Tell me. Is there one type of stationary points? In other words, Aliyah, what would we call this here? What kind of graph is that? Maximum or minimum?
A minimum.
So what kind of turning point would this have?
A negative.
No, a minimum turning point.
Oh, well, yeah.
And similarly, if you had a graph like this, you'd have a
Maximum.
maximum turning point,
Yeah.
right? So under stationary points or turning points, we need to acknowledge that at the stationary point or turning point, what is the gradient?
Zero.
Right. So in other words, this is the point where the gradient changes. So the gradient was negative here and it changes, becomes zero, and then it becomes positive. That's why we call it the turning point. It's the point at which the gradient changes. So under stationary points or turning points, you have two kinds. You have maximum and you have minimum turning points. And we class this under the nature of stationary points. The other thing you should know is that the gradient, the gradient at stationary points is, what's the gradient, Aliyah?
Zero.
Right, the gradient at stationary points is zero. Or Amy is still doing some of the um re the responses. So we can send them that in the meantime, right? Yeah, Aliyah, the gradient at the stationary points is typically zero. Well, it's always zero. What's another way I could write gradient? Remind me, what is gradient? What can I use to find gradient? What is this topic?
Um, the change in x in y over the change in x.
Which is, how do I write that?
Um, dy over dx.
Yes, when you find what derivative was that? What derivative is that? First, second, third.
Of the
That's the first derivative. So when you find the first derivative, when you differentiate, you're finding the gradient of the tangent or the normal. When you differentiate, are you finding the gradient of the tangent or the normal?
that would be the
Aliyah, were you here for the previous class?
yeah, I think so.
Or you should know that when you differentiate, you find the gradient of the tangent. Is this the tangent?
Yeah.
Right. So if I need to figure out the stationary points, what I need to do is I would need to differentiate my expression and put it equal to zero. Because when I differentiate, I'm finding a gradient. And we are saying that the gradient has to be equal to zero. Okay?
Yeah.
Right? So we find the first derivative. We find the first derivative. Right? Depending when the function, example, quadratic or cubic, the number of stationary points will change. Alia, do you know what I mean by this? Do you know what a quadratic looks like?
What
Alia,
was that?
I would like you to pay attention, right? A quadratic curve. Do you know what a quadratic curve looks like?
Um, I think so.
I think so. What's this?
A quadratic cube.
Right, that's a quadratic curve. So we know what a quadratic curve looks like. Do you know what a cubic curve looks like? I don't think you'd asked you that one before, right?
No.
So these graphs are quadratics. We are familiar with them. You can either have a minimum or you could have a maximum. And how much stationary points would these have? These are quadratics. How much stationary points do these have?
Two. Well, one each.
Asking like single,
Oh, one.
right? So quadratics generally have one stationary point. And the stationary point could either be maximum or minimum. Right, let me show you what a cubic looks like. So question, if if a quadratic cuts the x-axis at 2 times, what do you think a cubic will do? What does cubic suggest?
Cubic is three
3. So if a, remind me, a quadratic is x to what power?
to the power two.
And it cuts the x-axis 2 times. Like if I were to draw the x-axis, it cuts it at 2 times. So what do you think the cubic equation does? How much time do you think it cuts the x-axis?
Three times?
3 times, yeah. And what I would look like is this. Watch. It would cut the x-axis 3 times. Now, just by looking at this curve, how much stationary points are you seeing?
Two.
2, right? So a cubic generally has 2 stationary points, right? So we know what a quadratic looks like. Can you tell me the form of a quadratic?
Ax squared plus bx plus c.
Right, so we're gonna just write it as an equation. So y is equal to ax squared plus bx plus c. Okay, and if I wanted to figure out the stationary point for this, what would I have to do? The stationary point occurs when what is equal to 0.
When the gradient is equal to zero.
So we need to find the gradient. How would I find the gradient for this function?
Um, Differentiate.
Right. I would differentiate y with respect to x. So let's do that. If I differentiate ax squared, what would I get?
2ax.
2ax, that's correct. And if I differentiate bx,
You just get B.
I'll just get B. And if I differentiate C,
You get 0.
yeah. So if I want to find the stationary point, what I'm going to do now is I'm going to say that dy dx is 0. Remember, dy dx represents what? What does dy dx represent?
The change in Y over the change in X.
Which is a fancy way to say what?
Gradient.
Gradient. Correct. So we say 0 is equal to 2ax plus b. So what I'm doing here is I'm just giving you like a general idea of it. We'll do it with actual expressions just now. So in this expression, is it possible to find for x?
Yeah.
Yeah. So we would be able to find for x, you would say that 2ax is equal to b, and x would be equal to b over 2a. Right. Now that should look really familiar. You should have seen that somewhere before. Do you remember completing the square?
Yeah.
Okay. What was the formula for k? I mean h.
Um, I don't remember.
Aliyah, you know after a good start this morning, eh? You seem very, very shaky. Like you haven't done maths in ages. What's up with that? What's going on? I know you had the potential. When was the last time you practiced maths? Or like do a question?
Like last week.
Last 3 weeks?
No, last week.
Last week. It seems like it's a little longer. Okay. So B over 2A, that is also the formula for H. Okay. So Aliyah, let me just say we know what the X value is. So let me understand what we do so far. The stationary point occurs when the gradient is equal to,
0.
so you differentiate, you put dy dx is equal to 0, and you find for x. Once you have x, since we want to figure out a point, we want to figure out a point. Am I done? If I have the x value alone, is that enough?
Um,
What is that point made up of?
a X value and a Y value. So
Right. So if I have the x value, how am I going to find for the y value?
you could use the X value.
And do what with it?
You could replace the X with the value and find the Y. You could
We could
sub
replace the x with the value, like you want to substitute it into here?
Yeah, and you could
Right.
do that.
Yeah, you could do that. So plug x into y to find for y. Right. So that's the basic trend. That's what you're going to do. For a cubic, it's a bit different. The equation of a cubic will typically look like this. It's ax cubed plus bx squared plus cx plus d. Now, let's try to differentiate this. So I'll differentiate this more.
3ax squared plus 2b squared 2bx plus c.
Marks is something right. This is in the form of a what?
A quadratic.
Right. And why do we expect a quadratic? For a simple reason. When you solve a quadratic, how much solutions do you get?
1.
One. Ali, are you okay? You all right?
No,
Think
I don't
about
think
think about a quadratic. When we solve a quadratic and you factorize, how much solutions do you typically
Oh
end up
no,
with
you
for
get
x?
two. You get two.
We get 2.
Yes,
How much stationary points do we have for a cubic? Look at this.
2 points.
We have two
So
points. So it makes sense. So anytime you
yeah,
differentiate a cubic equation, you'll get a quadratic equation, right? Remind me, what's the gradient at the stationary point?
0.
So
So
we have to say 0 is equal to 3ax squared plus 2bx plus c. And what you will have to do now is you will have to solve the quadratic. And how much values for x will you get?
you get 2.
Right. And these x values would correspond to values here. Remember, this is the x-axis. So the two x values you get going to be values there. Solve the quadratic. You'll get two values for x. Right? So you have two values for x. How are you going to complete the question and actually find the stationary points? How are you going to do that?
Um, you factorize.
Right. We could either factorize or we could use the quadratic equation. Right? And to solve, you could either use factorization or the quadratic equation. So once you find the values for x, remind me, what are you going to do to get to get the corresponding value for y?
You substitute x,
Into the equation for
y.
right. Plug x into y is equal to cool. So that's what you had to know. The next matter, um, Aliyah, when we find the stationary point, does that tell us the nature of it? In other words, when we find the stationary point, does that immediately tell us if it's a maximum or a minimum?
Um, y-
Just
yes,
by if you look at a point, you could tell if it's a maximum or minimum without seeing the graph.
yeah,
You real good.
no,
So if I give you a point 2, 3, and I give you a function, a random function, you could tell me if that's the maximum or the minimum just by looking at it.
no.
No, you can't do that. So there's a way we use to figure it out, right? We use the second derivative, we call it. So you wouldn't really have to use that for a quadratic, and we know why. For a quadratic, how could we tell if it's a maximum or minimum graph? How could we tell that?
When you factorize,
No. Guys, how can we tell if a quadratic is a maximum or minimum just by looking at the equation?
the first point,
You're looking at which coefficient?
the
X squared.
x squared.
Aliyah is you had to do work, like because it seems like you forget a lot of basic stuff. And I'm not shaming you or anything, I'm telling you the truth. Like you forget a lot of basic stuff that you need to know. You can't have this, otherwise you're not gonna do good in that exam. Gotta sharpen yourself. Right? So for a quadratic, how do we figure out the stationary point? We just simply look at the coefficient of x squared, right? Um, for a quadratic, we can simply look at the coefficients of x squared to determine the nature of the stationary points. And Aliyah, what are the two cases? So let me just say we have ax squared. So we have ax squared plus bx plus c. When a is more than 0, is that a maximum or a minimum?
Maximum.
When a is more than 0, no. When a is more than 0, the graph looks like this.
Oh, well, minimum.
Remember, if a is more than 0, that means positive or negative.
Smile. That's like,
That's a smiley face,
yeah,
positive.
yeah,
And if a is less than 0, it's a sad face.
negative. Yeah,
So if a is more than 0, it's a minimum. And if a is less than 0, it's a maximum. So we can just simply do this for a quadratic, but we can't do that for a cubic. We can't do that for a cubic. It will not work. So for a cubic equation, we find the second derivative. So how do we typically write the second derivative? And what does the second derivative mean? Alia, do you know what the second derivative means?
um,
It's simple. It just means to differentiate a second time.
oh,
So let me give you an example. So let's just say we have y is equal to ax cubed. Let me use actual numbers. We'll just say we have y is equal to 5x cubed plus 2x squared plus 3x plus 5. So Alia, say we're trying to figure out the actually, let me get a question one time that makes sense. All right. Y is equal to x cubed minus 6x squared. I'll give you all time to copy down the theory just now. Okay, so Alia, let's just say we have this cubic equation. Remind me, if it's a cubic, how much stationary points we are expecting one time, like immediately? How much stationary points we know we're gonna have?
two.
But we don't know which one is gonna be the maximum or which one is gonna
Oh,
be the minimum. We don't know that.
yeah, yeah.
So first of all, we need to figure out the points, the stationary points. How do I find the stationary points?
You could differentiate
right? So we're going to differentiate this, do that from a fast,
x 3x squared minus 12x plus 12.
right? And at the stationary point, at stationary point, dy dx is equal to what?
0.
Right. And dy dx is just a fancy word for, a fancy term
Gradient.
for gradients, right?
Gradient.
So I'm going to say 0 is equal to 3x squared minus 12x minus and plus 12. Now, is there any way I could simplify this expression before I factorize?
Yeah.
Yeah. Well, what could I do?
Um, you could divide it by,
Yeah,
well, you
I
could
like where you're going at.
3,
Divide by 3, correct. 0 divided by 3 is,
0.
right? 3
Um,
divided by 3, just tell me the rest,
1. So you'll get x squared
right?
minus 4x
Right.
plus 4.
Now let's see if we could factorize this thing,
Mhm.
right? What do we have to multiply to get back x squared,
X by x.
right? And what do we have to multiply to get back positive 4?
Um,
But add to give you negative 4. So it has to multiply to give me 4, positive 4, and whatever the two answers are, when I add them, I should get negative 4.
mhm.
Let me just try 2 on 2. If you try 2 on 2, x squared, 2x plus 4. The only problem there is we're not getting back the negative 4.
Mhm.
We're not getting back the negative 4. So what do you think I should do?
You could, no, but you could put minus 2,
Correct, because minus 2 by minus 2 gives back.
positive 4, and when you minus it, you'll get minus 4.
Perfect. And let's just check that out. Again, x by x is x squared. X by minus 2 is minus 2x minus 2x minus 2x is minus 4x minus 2 by minus 2 is plus 4. So we're good, right?
Yeah.
So it's actually an interesting question. Hmm, that's weird. I'm gonna plot this thing real quick and see how it's looking. So you see in here that when you solve this, how much values for x you gonna have?
2.
2? You sure? Let me see.
Well,
So x minus 2 is equal to 0, x will be equal to 2, and x will be equal to 2. Are there really any difference?
no, so just be 1.
Yeah. Let me see how that looking. That's interesting. Kind of weird. I'm gonna plot the graph and send it on the chat. Oh, yeah, so let me show you what that looks like. So yeah, that's what the graph looks like. So at most, it could cut the x-axis 3 times, but in this case, the cubic equation cut the x-axis how much times?
1 time.
1 time. So this is not really an ideal example to use,
Mhm.
right? Let me get an ideal example. Oh, Amy, when you did the test, right? Was there sufficient space for each question?
Yeah, yeah, I had more than enough space.
All right. Awesome.
Also, I'm doing the integration past paper questions.
Okay, no problem. Nice.
Yeah.
Rather using your time. Okay, so Aliyah, I'm gonna change up the scene because our first one wasn't exactly a good example. So we have y is equal to x cubed minus 3x squared minus 4x plus 12. Right? Let's differentiate. Differentiate that for
You
me.
got 3x squared minus 4.
Minus 6x.
Oh, I didn't see the minus
Hmm.
3x squared. Sorry.
Yeah.
Minus
Um,
minus 6x minus 4.
right. Now this one's gonna be harder to factorize, but it is factorizable. So at stationary point, dy dx is equal to 0. So we're gonna have 0 is equal to 3x squared minus 6x minus 4. Now, Aliyah, um, let me think. Let's see. Um, wait, no, you gotta use you gonna have to use the quadratic equation for this one. Make a good example and not just make up anything.
Okay.
Okay, Aliyah, find one. Aliyah, are you there?
Yeah.
Okay, cool. So y is equal to x cubed minus 3x squared minus 9x plus 27. Can you differentiate that for me quickly?
Um 3x squared minus 6x minus 9.
Awesome. So we have 0 is equal to 3x squared minus 6x minus 9. Is there any way I could simplify that?
You can divide by 3.
Right, if I divide by 3, what would I end up with?
X squared minus 2x minus 3.
Right. If I factorize this, what will I end up with?
Um
To get x squared as x by x, what could we multiply to get minus 3, but add to give us negative 2?
minus 1 minus 3. No, wait.
Oh, no, no, minus 1 and minus
Minus
3 is plus 3.
3 minus hmm, minus wait. Minus 3 plus 1.
Minus 3 plus 1?
Mm-hmm.
Yeah, yeah, talking sense there. Because x by x is x squared, x by minus 3 is minus 3x plus 1x is minus 2x plus 1 minus 3. Yeah, that makes sense. So do we confidently have two different values for x?
Yeah.
Okay, so x is going to be equal to what? And x is going to be equal to what?
X is going to be equal to -1 and 3.
Okay, so we have the x value. That's not a point. We need to find the point. So how would I find the corresponding y value? So I have x. How am I going to find for y?
You substitute X um into the function, well, the equation.
Right? So which equation?
Um, Y,
Y, right? That's correct.
yeah,
So we are going to say y is equal to -1 cube minus 3 by -1 squared minus 9 by -1 plus 27. So I want you to quickly plug that into the calculator for me and tell me what you're getting for y.
um, you get 32
So we have y is equal to 32. So what is that point then? So what's our
minus
first point?
132.
Right? So our first point is, well, we will summarize after. So x is equal to -1. And let me do this one real quick. So the point for this one is -1 comma 32. But you could just look at it and tell me that's the maximum or the minimum. You could look at it and tell me if that's the maximum or the minimum.
Um, no, can you?
No, you can't. You don't even have anything to compare it to. So let me try x is equal to 3. I'm going to plug that into y. So y is equal to 3 cubed minus 3 by 3 squared minus 9 by 3 plus 27. Plug that in quickly.
You get 0.
You get 0.
Mm-hmm.
Hmm. Let me see. 3 squared by 3 squared is 9. I'm at minus 27 plus 27. That cancels off. Minus 9 by 3. Yeah, yeah, you get 0. So what's that point then?
X, sorry, 30.
No, I will help you. Um, I'll help you figure out which one is the maximum and the minimum just by looking at it. You see, you could not figure it out before, but when you have the two results there, you can compare. So if we're looking at height, we're looking at the x value or the y component. If we want to look at height, how high
The
or
X,
how low
no, the Y value.
the y value. So which one
Yeah,
goes higher, 32 or 0?
32
So I bet you 32 is the maximum turning point, and 30, since it goes down lower,
is the minimum.
but you need to show, you need to find the second derivative though, right? You need to find the second derivative. So let's do that. Let's find the second derivative. So my first derivative, this over here, this is first derivative. This is your first derivative. Now I need to find the second derivative. So if first derivative means to differentiate once, what do you think second derivative is?
To differentiate twice.
Right. So you need to be familiar with the notation. When we find in second derivative, if your original expression was f of x, it'll be f double prime x. And if it was dy dx, the second derivative would be written as d2y dx squared. d2y dx squared. So when we're going to find the second derivative, we're going to write d2y dx squared, and we're going to just differentiate the first derivative. So let's do that. So Aliyah, you're going to differentiate the first derivative. So the first derivative was 3x squared minus 6x minus 9. I'd like you to differentiate it for me.
Um, 6x minus 6.
Right. Now, there's a rule. If, so the rule goes like this. If d2y dx squared is it very similar to the case of the coefficient of x squared. Remind me earlier. If the coefficient of x squared is positive, is it a maximum or minimum?
If the coefficient of
For a quadratic. If the coefficient of x squared is positive, maximum or minimum?
it'll be minimum.
Minimum because it's a smiley face. Positive.
Yeah, yeah.
It's the same thing over here. If d2y dx squared is more than 0, it suggests that that turning point is a minimum. Right. And similarly, if d2y dx squared is less than 0, is a sad face. So it's a maximum. Now, just because you find one as the maximum, that don't mean you could just write the other one as a minimum. You have to do the full working. Right. So Aliyah, let me show you what we're gonna do now, right? So once you have the second derivative, and you would have had different values for x, and you have two different points.
Yeah.
So what you're gonna do is you're gonna say, for instance, which one we thought was the maximum again? -132 or 30?
-132.
Right, because the y value was bigger. So that means
Yeah.
it'll be 32 would be over here, and well 0 would be over here. You
Mm-hmm.
cannot see how it looking. All right. So let me try when x is equal to -1. So when x is equal to -1, remember when you plug in an x value into any derivative, you draw the vertical line and you say wherever the x value is and you plug it in, big equal sign here. So that'll be 6 by -1 minus 6. What is -6 minus 6?
0.
Those I was
Sir,
not going to say those
I
are
could
0.
I coming back, right? Sorry, hold on.
Okay. In the meantime, Amy, what is -6 minus 6? Is it 0?
It's -12.
-12. Yeah.
Mhm.
What does that fall under? D2y dx squared more than 0 or D2y dx squared less than 0?
Less than 0.
So since it's less than 0, right? Since D2y dx squared is less than 0, the point -1 comma 32 is a what?
A minimum.
Yeah, that's how it goes. So that's how you write the proper working for these questions. Right. So since d2y dx squared was less than 0, the point minus 1 to d2 is a maximum. So we were correct. Is a maximum turning point. All right, Aliyah, are you back? Okay, I'm guessing Aliyah isn't back. Amy, let's finish it. So was x is equal to minus 1 the only x value we found?
No, you also find the x is equal to 3.
Right. So we need to test that case. Now, just because we find um that minus 1 to d2 is a maximum, we can't just say the other one is a minimum, eh? We can't just do that. Understand?
Yeah.
Right? So then you're gonna say when x is equal to 3, and you're gonna put the proper work in, you're gonna say d2y dx squared, you're gonna put the vertical line, and then you're gonna say x is equal to 3, right? And that whole thing would be equal to the 6 by the 3 minus 6. What is 6 by 3 minus 6?
Well,
12, right? And since I'll write the statement down, you need to write the statement. So we're gonna say since d2y dx squared was more than 0, the point 3 comma 0 is a minimum point, right? So yeah, that's basically the gist for stationary points / turning points. There's nothing more I could really say. Aliyah, are you back?
Yeah, sorry. I kind of have an emergency, but it's okay.
You have an emergency, a really bad emergency.
I don't know, but it's okay.
You don't what? Okay,
No,
let
but
me
I in
continue.
class. I wouldn't be.
Okay, well, let me continue. If the emergency gets really really bad, then you'd be excused. Okay, um, so we were saying, okay, first things first. You know how to find the points, right? Walk me through the steps. How do we find the point? How do we find the stationary points?
You differentiate the equation that they give you. So you basically you find the first derivative,
Find the first
and
derivative. Mm-hmm.
you say that the stationary point is equal to 0. No, yeah,
Yeah.
and yeah.
If it,
So
the
you get
stationary point is the gradient, so you say that the gradient is equal to 0.
yeah. So you put the the first derivative equal to 0, and you factorize out.
You put it equal to 0 and you factorize the quadratic and you find the
Yeah,
different values for x. Once you have the
yeah.
different values for x, what's the next move?
You could find for y, so you substitute the x value into the y function.
Right, you put in the x value into the y function, correct?
Yeah, and you get your points.
Right, and you get your points. Now that you have your points, you need to figure out which one is the maximum and which one is the minimum. To do that, what are we gonna do?
Um, you find the when you get the two when you get your first x value and y value, you you find for your second derivative.
Right, you need to find the second derivative. Now,
Mm-hmm.
when you find the second derivative, is going to be in terms of x. So what you're going to do is, depending on the x values you got for the stationary points, those are the x values you're going to plug in. So when x is minus 1, d2y dx squared is equal to minus 12. So that's more than 0 or less than 0?
Less than 0.
That's less than 0. So if it's less than 0, it's negative. It's sad. Maximum point.
Mm-hmm.
When x is 3, do the same thing. You get 12 positive, happy, minimum point. So that's it. That's it for stationary points. We can start past papers now.
Okay. Give me
So
a few minutes,
okay,
please.
sure. No problem. So Kirsten, Amy, in case all they want to copy down the notes, or they can start, right? And I'll go let me know when I finish. Copy down everything. Right? Kirsten, good day, good day. It coming out late because I knew it wasn't lessons before. So try to understand what's going on. Let me know if you did this in school as yet. If you didn't, that's okay. I'm going to do questions on it just now, and you could see me do the questions in detail, and you can follow along. And also try the questions I'm going to give. All right, just give me a second, guys. All right. So Amy and Kristen, you all could copy down the notes. So Amy, you start copying down the notes.
Yeah.
Okay, cool. Right, and Kristen, just let me know if you copy down the notes. Drop it in chat. Oh, Kristen, I see you on mute, but I'm not hearing you. Now, Kristen. Okay, Amy, you have everything that's on the screen right now?
No, I was on the third point.
Okay. Take,
But
take.
you can, yeah. You can probably scroll down to the third one. Yeah.
So Amy, is there anything you learned additionally or like you learned all of this already from discovering?
Yeah.
Okay, cool. Right, Amy, have everything copied down?
Almost finished.
Okay, no problem.
Okay.
Okay, cool. I'm gonna scroll down. Right. Kiara, like you wake up late.
Yeah.
Hmm. Your mom wake you up?
Yeah.
Oh, you just managed to wake up this late, boy. Um, Sports day was good.
Yeah.
Okay, okay, nice, nice. Not much words. Still waking up. Did you ever do this in school as yet? Stationary points?
Um. Yeah, I think so.
Okay, that's where you find the gradient
No, wait,
equation.
no.
This is like the last topic in differentiation. All right. Um, Amy, I'm gonna know your age.
I'm actually looking for the Quebec right now.
Right. So Amy, how's sportsy? Forget to ask you. Sportsy was good.
Oh, I didn't go. I wasn't feeling so the morning, but I hear it was good. My house win, so yay.
Okay, okay. And
Yeah.
and you didn't go.
But I
Okay.
was tired because I was making costumes for them and pom-poms and things. So,
Oh, you was making the costumes by yourself.
well, not by myself, well, with one of the teachers and the pom-poms. So I was
Okay.
kind of tired. The Tuesday evening.
Well, that's valid. That's valid.
Yeah.
Right.
Okay. I finished with the weekend.
Okay, cool. Right. Kristen, what about you? Kira, I feel like you gotta look back at the recording and check the notes. Because we finished with stationary points. Next thing we're gonna do is we're gonna do questions on it. Right? Second derivative. Akira, you ever do second derivatives before?
Yeah.
Then you should have done this before. Yeah, once you do second derivatives, um, that's typically tied in with stationary points. Oh, Amy, you finished?
Yeah.
All right, Kirsten, let me know if you're finished. Okay, cool. Cool. So now we can start questions. Let's do that. So we're gonna start off with easy and then we're gonna progressively get harder. Okay. As a question one is gonna be a very, very simple question. Right? Questions. Right. And Kiara, I would like you to try the questions on somebody working if you can. So find the stationary point. Right. So I want you all to try that question. Just take 2 to 3 minutes. That should be an easy question. All right. Kiara, do you know what to do for question one? Yes or no?
I'm doing it right now.
Okay, so you know what to do.
Yeah.
All right. Yeah, that's correct, Amy. Perfect working and everything. Right? Excellent. Right, so just waiting on a response from Kirsten and Kira. Kirsten and Kira, try question one and send it to me. Kirsten, you having any trouble with question one? You almost done? Cool. All right, Kirsten and Kira, how are things coming along? Didn't get any responses from you guys yet.
Almost done.
Okay. All right, so Amy, um, let me explain a concept. I'm gonna teach you all an additional concept, right? So, you know how a cubic equation is kind of look like this?
Yeah.
So you know how for a quadratic, there's something called a turning point where the gradient turns. The gradient is no longer negative, it's positive. Vice versa. Well, it's a similar concept for cubic equations. If you look at this graph, and there's a point where starts to transition from a maximum to a minimum.
Yeah.
Okay, we call that the point of inflection. So that's the next thing I want to teach you all. It's additional, it's like extra, but it could come. It's on the syllabus. It's never came before, but it could come. Yeah, Kira, that's correct. That's correct. Kirsten, I'm just waiting on a response from you. All right, Kirsten, you let me know how much time you need again. Uh, I can't give you too much more time though. All right, Kirsten disconnected. Yo, I'm gonna put the answer on the chat. Aliyah and Kirsten, when you're looking back at the recording, you can see how I did the solution. So Amy, walk me through the steps. Walk me through the steps. Actually, no. Kira, explain to me how I would do this question. Tell me. Kira, how am I gonna do this question?
Okay, so finding the stationary point of y equals x squared minus 4x plus 3, and we
Mhm.
had a determinate nature. So we started with dy dx and put in that is equal to 2x minus 4, and
So,
then
I don't even
because
know. Why we finding the first derivative? First derivative is also known as what? What's dy dx? When you find dy dx, what are you finding for?
the gradient
The gradient. That's exactly what I want to hear. At the stationary point, the gradient is
0.
perfect. So that's why we find dy dx. Yeah, awesome. So dy dx would be equal to 2x minus 4, like you said. And then we're going to write the statement at stationary points, dy dx is equal to 0. What next?
Um, then you put 2x minus 4 equals 0, and
Correct.
then you will switch over the thingy, so it will be 2x equals 4, and then it will be like x equals 4 over 2, and then it will be x will be equal to 2.
Perfect.
So basically, you're finding for x.
Yeah. And once I have x, is that all? Is that a point? Is x a point?
Yeah.
So you're telling me x is equal to 2 is a point. Think carefully what you're saying. What is that point? Remind me, what is that point?
Um.
What does that point consist of? Is not a trick question in a graph. What is a point? A point consists of
X and y.
x and y. That's correct. So you have an x value, but you don't have the y value. So is this our point?
Well, yeah, that's what I mean. X is a value. That's what I mean.
Right. X is our value.
And then, well, now we find then for y. So if x is 2, you plug it into the equation. So that would be y will be equal to 2 squared minus 4 by 2 and then plus 5, and you'll get minus 1.
Oh, that's plus 3, huh? That's 3.
Plus 3. Sorry, I write it wrong in my book. What? Sorry, plus 3.
So 2 squared is 4. 4 by minus 4 by 2. That's minus 4 plus 3 is minus 1.
Yep.
Right?
Mm-hmm.
Mm-hmm.
And then, well, the points will be 2 and minus 1.
Yeah. Now we need to figure out if there's a maximum or minimum. Now, for a quadratic, we don't necessarily have to find the second derivative. You could look at it and figure it out. But we're gonna find the second derivative anyways. But look at this. What's the coefficient of x squared? Come on, what's the coefficient of x squared in this question? Kira, what's the coefficient?
Um, how
So
would it
what's
be?
what would it be? If I just have x squared, that's the same thing as having what?
I don't know. I feel like I want to put it
Okay. How much x's do I have here?
2,
How much x's I have here?
1,
So the coefficient there is 1. So how much x squareds I have?
1,
1. So my coefficient is 1. Now is 1 positive or negative?
positive,
All right. So if it's positive, then it's a smiley face. And since it's a smiley face, it's a maximum or minimum.
a minimum.
Correct. Now we could figure that out, but we need to show the second derivative. So let's do that. So to find the second derivative, that'll be d2y dx squared, and I want you to differentiate 2x minus 4 for me. Amy, I noticed that you found the point, but you didn't find the nature.
I
Anything
know,
else?
I realize that.
Yeah.
I'm going to find it right now.
Right. So Kira, let's do the nature. When you find any nature of a stationary point, you're gonna find the second derivative. So Kira, the first derivative is 2x minus 4, so you're just gonna differentiate this again. So if you differentiate 2x minus 4, what would you end up with?
Um, 2,
Yeah, just 2. Now, that's really simple, right? And 2 is 2 less than 0, is 2 more than 0. What is 2?
more than 0.
So we're gonna say, since d2y dx squared is more than 0, I could just write d2y dx squared more than 0. The point 2 minus 1 is a what? Tell me, Kira. Since d2y dx squared is more than 0, it's the same concept for coefficient. If the coefficient is more than 0, meaning a positive, is a minimum. If it's negative, is a maximum. So since it's more than 0, it's positive, it is a Kira, tell me fast. 2 minus 1 is a maximum or minimum? Minimum.
Um,
You didn't get a chance to copy down the notes, but if d2 by dx squared is more than 0, it's a minimum. If it's less than 0, it's a maximum. It's the same concept. If you're more than 0, are you positive or negative?
positive.
Right? So if you're positive, you're smiling, and if you're smiling, that'll be a minimum. It's the same concept.
Okay.
So since d2 by dx squared is more than 0, the 0.21 is a minimum. Okay, so I'm going to give you all one more question, and then we're going to move on to something called point of inflection, which is on the same topic. It's just like the last thing, as a bonus, really. Okay.
Rajiv, I just realized a mistake I made in the test you sent me. It's a really dumb mistake, but I just wanted to say one time. When I was doing stationary points, I made like a huge mistake. Um, I thought that when you find the second derivative and it was negative or less than 0, it was a minimum. Because
Yeah.
I was thinking that, oh well,
And that,
negative y-axis going down lower. So, so yeah, I just saying one time, but I realized now that it was is the other way. Yeah. But I just want to fix it and send it back. But it was just one question, well, one part of a question.
okay. All right. So it's the same concept for coefficient, right? It's the same concept for coefficient. If the coefficient of x squared is positive, then it means it's a minimum. I know it's kind of weird, because if it's positive, you think it'd be maximum, but no. Right, so I'd like you all to try this question. Given the function y is equal to x cubed minus 6x squared plus 9x plus 2, find, I want you all to find the coordinates of the stationary points. And I would like you all to determine whether each point is a maximum or minimum. Right. So I would like you all to try that question. All right, are you guys getting through?
Yeah.
Okay, okay, nice. Kira, did you ever look at point of inflection?
I think so. In school, probably.
Okay, well, I'll go over it anyways, right? But Amy, you getting through this question like you gain actual values?
Um, well, I made a little mistake. So, but yeah, I guess so far.
Okay. All right, are you guys getting through with question two? It's been quite a while. Been a little while. Kira, how things going?
Good, I think.
Okay. Okay, Amy, let me know which part you reach. You get through with the coordinates?
Yeah, I find the second derivative right now.
Okay. Um, Amy, so for question two, right? What did you get for the points?
I get 1, 6, and 3, 2.
Hmm. 1, 6 on 3, 2.
Yeah, I said I'm not working right now.
All right. All right. So let's see what we have here. So 1 and 3 are correct. And then you have, right, so the stationary points, you got the correct stationary points. All right, let me check the nature of it. So that will be 6x minus 12, 1, 6. Okay, excellent job there, Amy. That's it. That's it. So I'm gonna do the working on the board quickly, right? So given the function y is equal to x cubed minus 6x squared plus 9x plus 2, find the coordinates of the stationary point. So by now we should know that anytime we see stationary points, we have to find the first derivative and put it equal to 0. Because at the stationary points, the gradient is 0, right? So I'm gonna find dy dx. So dy dx would be equal to 3x squared minus 12x plus 9, and I'm going to put that equal to 0. Now to simplify this, we could divide throughout by 3. If we divide throughout by 3, we'll end up with x squared minus 4x plus 3 is equal to 0. Right? So we expected a quadratic when we differentiated, because this is a cubic equation, and a cubic equation could have two turning points. So, Amy, what could we multiply to get 3, but also add to give us minus 4?
This one, straight.
Yeah, minus 1 and minus 3. Right. So, x would be equal to 1, right? And x would be equal to 3. Now, they're asking us for the points, so we're not done. We have the x component, but we need the y component. So what we're going to do is we're going to plug in the x values into the y function. So when x is equal to 1, y would be equal to 1 cubed minus 6 by 1 squared plus 9 by 1 plus 2. Right? So y would be equal to 1 minus 6 is minus 5 plus 2 is minus 3. Y is equal to 6. So this point here, the first point is 1 comma 6. Right? I don't have enough space. So when x is equal to 3, y would be equal to 3 cubed minus 6 by 3 squared plus 9 by 3 plus 2. So 3 cubed is 27. 27 minus 54 is minus 27. Minus 27 plus 27 is 0. So y is equal to 2. So this other point is 3 comma 2. Right, now we need to find the add page after. We need to find the second derivative to determine the nature of the points. So I'm going to find that. So d2y dx squared d2y dx squared would be equal to, okay, so the first derivative was 3x squared minus 12x plus 9. So for me to differentiate this again, I would end up with 6x minus 12. So d2y dx squared is equal to 6x minus 12, right? So the first one we're going to look at is when x is equal to 1. So it's going to be d2y dx squared when x is equal to 1. Right, so when x is equal to 1, you'll end up with 6 by 1 minus 12. 6 minus 12 is minus 6, right? So since the second derivative is less than 0, it's a maximum. Right? Mhm. And d2y dx squared, right? When x is equal to 3, that would be equal to 6 by 3 minus 12. That'll be 18 minus 12. 18 minus 12 is 6. So since d2y dx squared is more than 0, the other point is a minimum. Okay, so that's that. Right? Let's briefly touch on in points of inflection. Right? I started class a bit late, so I'm going to end class a bit late, like in the next 4 minutes. Shouldn't take long. So what exactly is a point of inflection? Right? A point of inflection is the point where in a cubic equation, it's hard to see a change from a maximum to a minimum. Right? So a point of inflection. This is only for cubics. This is only applicable to cubic equations. And it is the point where there is a change in turning point. What do I mean by that? Well, this is what I mean. So imagine you have a cubic, right? Imagine you have a cubic equation. This point here will be the point where there's a change from the maximum turning point to the minimum. So Amy, you understand that well?
Yeah.
Right? So this over here, this is my point of inflection. And you could visually see it's the point where the turning point is changing. Now we need to know the special property of our inflection point, or characteristic of it. So at the inflection point, so Amy, you know how at a stationary point the gradient is 0? Well, at the inflection point, d2y dx squared is equal to 0. And Amy, let me try to draw some patterns, right? When we were dealing with, like, when we were dealing with quadratics, let's observe what was going on. This was a negative gradient. This was a gradient of 0. And this was a positive gradient, right?
Yeah.
Amy, right? And this, so dy dx here would have been negative. Dy dx here would have been positive, and dy dx here would have been equal to 0. I want to draw a comparison to that and this, and you see it's a similar situation. Over here, dy dx is, right? So over here, dy dx is less than 0. Over here, dy dx is more than 0. And over here, dy dx is 0. You see what's going on? See how kind of similar, right?
Yeah.
Yeah. Because less than 0 means negative, and more than 0 means positive. So it's the same kind of situation where we have a negative, 0, and a positive. That real cool, right?
Yeah.
Right. So let me get a question real quick, and that'll be it for class. Right. So, Amy, for a cubic equation, you're expected to have how much inflection points?
1.
One, right? Cool. So, let's begin. So, the property we're going to exploit here is that at the inflection point, the second derivative is equal to 0. So what you typically have to do is you'd have to find the second derivative. So to do that, you find the first derivative. What will be the first derivative, Amy? Let's speed through this. What's the first derivative?
3x squared minus 12x plus 12.
Right, and again, we'd have to differentiate to get the property for an inflection point. So at the inflection point, the second derivative is equal to 0. So I'm going to find the second derivative. So what would that be?
6x minus 12.
Correct, 6x minus 12. And at the inflection point, the 2y dx squared is equal to 0. Right, so we're going to say 0 is equal to 6x minus 12. And if you make x the subject to the formula, it'll be 2. Some of you okay with that? Some of you okay with that, Amy?
Yeah.
Right? Kira, is there anything hard to understand here? Like, is there anything tying you up? Or so far it makes sense?
So far good.
Okay, cool. Kirsten will drop in the chat how you feel about it. And it's the same procedure. Once you have x, you can just find for y. Nothing that didn't change. So if you have x is equal to 2, to find for y, you're going to plug it into the cubic equation. So that'll be 2 cubed minus 6 by 2 squared plus 12 by 2 minus 8. So 2 cubed is 8. 8 minus 24 is minus 16 minus 16 plus 24 is 8. 8 minus 8 is 0. Somebody just confirm that. I don't trust my mental maths right now. Amy, is that mental maths correct?
No. Oh, wait, no. I thought you were answering the calculator. Yeah, it is correct.
Okay, well, would. Would. That's surprising. So the point of inflection for this graph is, right? So the point of inflection so imagine you had a graph. So what it could bring, right? They could bring a question and ask for the maximum, the point of inflection, and the minimum. You guys know how to find the maximum and the minimum, and I just showed you all how to find the point of inflection. So you're gonna find the maximum and the minimum as usual, right? And if they ask you to sketch a graph, all you're gonna do is you're gonna put on the graph, you're gonna put the point you get for the maximum, put the point you get for the minimum, and put the point you get for the point of inflection. All right, that'll be like a 6-mark question. How are you feeling? Are you feeling good?
Yeah.
Okay, nice. Like I said, it never brought points of inflection before, but it's not a hard thing to learn, and better be safe than sorry. So yeah, um, that's it for class today. I will send you notes immediately, right? Um, Amy, I'm not seeing you tomorrow. I will see you on the 29th to make up for that session, right?
Yeah.
All right. Kiara, thanks for coming to class today, even though it was a bit late. I'm looking at you now. And Kirsten, thank you for making it to class right after your lessons. So hopefully have a blessed day. Later, everybody. Later, everybody.
Bye bye.
Yeah.